Hunchback. Now, I've had some questions and I thought we'd go through it. Let me find them. Let me find them. Because quite rightly, if somebody's joining in now, they won't know what's been going on. Oh, there we go. So, question number 1. You mentioned about double buffering when scrolling. What's this all about? Right, double buffering. Double buffering is when you're scrolling from one side of the screen to another. So if we press F6 on this, hopefully got no breakpoints. Right, so when we are scrolling, right, when we are scrolling, we have got 8 frames to work with because the scroll moves 1 pixel every time. So we have 8 pixels to perform the scrolling function. Now, double buffering allows you, because if you try to scroll the screen without double buffering, you'll never make it, because you need more CPU time than you have in a raster screen. So there's a finite amount of CPU time between here, well for us it's here, down here, and then back up to here. There's a finite amount of CPU time, because once the CPU is encroached on here, you get screen tearing, yeah? And you've seen that where we've had timing issues and we've had to reorder things. Now, what double buffering does, it allows you to use 2 screen areas, yeah? So, you have a point, let me see if I can get this drawn out. Let's use paint. Oh, we got paint on here. Right. So, this is our timeline, yeah? Oh, and I'm rubbish. So we got 1, 2, 3, 4, 5, 6, 7, 8. We have 8 pixel frames. Alright, see you later, Mikroman. We have 8 pixel frames to work with. Now, in Hunchback, we stabilize on frame 4. So 1, 4. So we stabilize there. So when Hunchback stood still, that's frame 4, and we always center on frame 4. So here is stopped, but as you can see, we are halfway through a character, yeah, here, and we're halfway through a character here. And this allows us to make sure that we prepare the double buffering, whether we're going that way or that way, yeah? So, if I change colour now, so if we're scrolling this way, scroll, I can't, oh dear, I wish I had a light pen. If we're scrolling this way, right, that means we are going to be moving the pixels in this direction, yeah? So we have to prepare the next screen, because you have to remember, it's alright setting the X scroll, which allows us to move the pixels. It moves the pixel scroll, and that takes no time. It's 3 instructions, 4 tops. But because of double buffering, where we have 2 screens, right, and we're doing that with the screens, we are swapping them over. So first things first, on this one, yeah, hang on, let me just make sure. No, it's on this one. On this one, we have to copy the screen of where we are now, of the screen where we are now, onto the buffer. But if we're scrolling that way, we shuffle everything over in that direction. So everything gets moved over in that direction. That's what that frame does. So we cut a piece down. The next frame is we evaluate the border. Excuse me. Go away. So we evaluate the border, and what we do with evaluating the border is we go to the map. We find out which tile column we're on the map, and we use the delta as the point for that. We grab that column. Yeah, we grab that column of characters, and then we put it into the column buffer. Yeah. The next frame here is we let me just check. Evaluate. Right. In the next one, we draw the side buffer into the shits, and we draw what we've evaluated in the last frame. We draw it on the screen that you can't see, the screen that's going to be coming up. And then the very last pixel, which is here, we swap screens and copy the color. So we flip the screen, and then we copy the color RAM from one to another. And that's why, if you look here where I've got my mouse pointer, if I scroll, here we go. You see where it encroaches to here, right? That's because it's copying the color. We haven't got a double color RAM that we can mess around with, and so we do get a bit of override on the screen, but because it's the color RAM, it's not that obvious. And that's what we do by color buffering, because once we've swapped, so we was on this screen, we're now showing this screen, yeah? So if we're scrolling again, then we start working on this screen, and we run through the same steps. So we're still scrolling that way, run through the same steps, but then we swap the screen, and then the screen's constantly doing that. It's swapping between, and I think what I've got it is set to 4000 and 4400. They're the two screens. Now, if we are scrolling that way, so in essence we're pixel moving in that direction, it's exactly the same, but we're using it on this pixel, this one, and this one. Yeah. And then this is the jump. This is the jump one. So we do the screen swap. And that's what we mean by double buffering. And it allows you to switch the screens every time you need to do the screen, the column move, the character move. Instead of copying the screen, you just flick the screen address to the new screen, because you've already done the copy, you've already done the evaluate, and you've already drawn the new column. You just flip it. Then you only have to concentrate on copying the color. Then you carry on. You evaluate the new screen. When you get to it, flip to the new screen. And that's what double buffering is. Right. Well, you can't do it in the one frame. Do you know when we have got a single pixel, yeah? That we have. So the pixel is these two pixels. So if you go in left, you have to do the copy on pixel 0, and right, I think it's on pixel bit 7. There's not enough CPU time in the raster to do all that. If you're not bothered about raster, then yeah, you can do it on that frame. Not a problem at all. You can do it on that frame. If you're not bothered about screen tearing, because you'll get a little bit of screen tearing at the bottom of the screen because there's not enough CPU time. But are you copying the colour as well? Yeah, if you do it and try copying the colour as well, so you're moving the colour across as well, you won't have enough time. You'll end up with a lot of screen tearing. You'll end up with the screen moving and then the colour sort of catching up. And so if you're not bothered about the colour, because that's why some games are just two colours, because they're not bothered about the colour. Yeah, I mean some use the multicolour mode to give them a fake 4 colours, but if you're not bothered about the colour, you can do it in that one frame. You can do the whole lot in one frame because we copy the colour. But if you're evaluating a tiled map, then you have to work out which tile you're on. You have to work out what characters of... Let's say if we have tiles with 4x4, you have to work out which thing, and that's why we use the different frames. And basically all you're doing is you're taking little bites. Each frame you're taking a little bite, because on those frames you wouldn't be doing anything. Yeah, they'd be sitting there. What they're doing on those frames, capturing your control, updating the sprites. And so you can, and that's why when it's running, this is the scroll bit here. I think that's the scroll bit there, the brown bit there. So if we try and move, there we go, and go up, that's the scroll. But as you can see, on a normal without the screen copying, we only use what, 30 raster lines to do it on every frame, except for the colour screen copy. Right, next question. Why are we switching screens for the HUD? Good point. Good point. We don't need to, really. We don't need to, really, because what we can do is if we wanted to, we could game logic. Yes, screen switching would be imperative for any sort of series. Oh, for the HUD? No, because here, right, here is where we're turning the X scroll off, and here is where we are. In fact, I'm actually turning off the screen switching. Hang on. Yeah. So I'm actually turning off the screen switching and then turning it back on. The boys playing up. So the HUD is really not being screen switched because we're identifying the raster point. Aston. Because we're identifying the raster point, which is here. So this is our raster line that defines the HUD, and this is our raster line that stops the HUD. We can fix the screen address here, so we don't need to screen switch on the HUD. And it looks like we don't. It looks like I've done it already. So let's just confirm. So that's setting it back. No, sorry, that's not it. That's the character memory. That's the character memory. No, we're not using. Well, using two screens. All right. So we're using 2 screens. Where's the scroller? Right, so we've got screen RAM, so that's screen 1, and then screen RAM 2. The other screen is the colour RAM, yeah? So they're the 3 screens. But in essence, just for the screen, ignore colour, we're only using 2 screens and we're just flipping between the 2. So in terms of the memory map, so if I build this again. What's the matter, Aston? You're a bit restless today. So so here we go. So here's the memory map. There we are. There's the screen area, and there's our shadow. So we've got the screen area from 4000 to 4300 FF, and then we've got the shadow area 44 to 48 FF. At the moment we're copying it, but we don't need to. That's what I'm saying. We don't need to copy it. We can fix it to this screen area, right? Sorry, this screen area. We don't need to make it switch because we know which screen we're in, because where are we? This variable tells us which screen we're on. So it doesn't. At the moment we're copying it. Yeah, we're copying it to the HUD is being copied to the 2 screens. I'll show you what I mean. Because we have. Right, draw HUD. So we're in map. By the way, I've got live share on. So if you want to join in the fun, if you've got VS Code, there you go. We're going to have a play with that, see if it's going to work. Right, so we need map. So we need game map. Right, so where's the HUD? Where do I draw the? Here we go. We'll draw the HUD here. But then again, we're only drawing it in one place. Am I copying it? Ah, here we go. This will prove it. Right, this is the quasi indicator. Yeah, this here. So I've stopped it updating screen 2. So if I redo it. Hey. So if I redo it, this quad indicator will go funny when it starts scrolling. Because when we start switching screens, can you see? Because I'm not updating the second screen. So what we can do here is we can then, we're going to stop the screen switching on the HUD. Yeah? So what we need to do is, where's my macro? Let's find my macro. So initialize screen. Here we go. Here we go. Here we go. This is it. This is what we need. This is what we need. So where we where we turn, where we switch character sets, which is here, we're going to now got to think about this. Because we need to put it back to where it come from. No, it won't alter. I mean, it's the same. It's the same. Yeah, it's the same. We just need to. What we need to do is we need to take note of what it is. Right, so I'm going to push this to the stack because we need to keep an eye on what it is, yeah. And then we are going to clear out and right. Where's my website gone? I need the address.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, thank you for follow. Oh well, those alert works. Thank you for following. Not quite sure. Oh, there it is. McKeerick. Thank you. I don't want to destroy your name. Right, let's just change my MAJIKEYRIT. There we go. That should change your name. There we go. New followers on the screen. Right, back to this. Right, Vic to addressing system. That's what we want. So our memories. Alright, so that's the character set. Our memories here. So we're flipping between that one and that one. Oh no, 4,000 to 4,000. Ah, right, okay. So, right, so our screen 1 is there, and our screen 2 is there. So it's this bit we're looking at, this one here. So I need to. This is right. This works because we're clearing it out. Yeah. So I want to clear that out, and that will reset my thing. And then here we are just going to do. We don't need then this. We don't need to do that because we've pushed it onto the stack. So I just pull it back off the stack, and that should fix the HUD. Right, so if we run it now, our quasi indicator should. Oh, well, not quite like that. What did I do wrong? That sets it to 0. That's right. Oh. Right. So remember the last time when we moved and we weren't updating the thing. Oh, we've got a bit of a glitch here. This was jumping, right, when we started scrolling. So let's do it. Let's see if it starts jumping when it scrolls. And there you go. We are no longer HUD switching. But we do have a bit of a glitch there. And that is. That was at the top, wasn't it? Yeah, that's at the top there. So it's here. Right, let's take a few of these out. Has that sorted it? No, I may have taken too many out now. Let's try again. Let's put half of them back. Any glitching? Oh, we've just got a bit of glitch in here. Right, let's put a couple more back. Or you could get out for a kickoff. Right. It's still glitching a bit on the colour. Put them all back in, see what happens now. Maybe it was just yeah, it's just... Right, maybe it's just one no-op too many. There we go, fixed it. One no-op too many. Right, so this should now not be screen switching, and we can test this. We can test this because we copy the HUD. We copy the HUD. Right, so we evaluate the HUD here, and then we copy it to the other screen. So I'm going to take that away, so it's not copying it to the second screen. Right, and we should still see the HUD when we scroll. Here we go, and it shouldn't move. There you go. We are no longer screen switching for the HUD. The HUD is just using one bit of memory, which is on screen 1. So this is 4000, so this is going to be what, 443, somewhere around there. So this is no longer screen switching. And that means we now save some memory because we can use this memory on screen 2 to store stuff if we need to. There you go. So that answers that question. What happens when the score updates and you're on the other screen? We just update screen 1, mate. Because remember, when we get to that raster line, we turn back to screen 1 to show the HUD, and then we go back to the whatever screen it was on before. So it doesn't matter. We just update that memory location because the raster, you know, remember here, the raster here. So we're waiting for 210. Okay. Right, so that answered that question. They were the two that I was asked during the week and the weekend. Any other questions before we carry on? No? Right then. So, a certain Stuart that we know and love has been messing around with the HUD graphics. Now I've got them down here. And this is what he's come up with. Look at them. Let's make it bigger so you can see. Look at the hearts. Look at the hearts on that. And he's messed around with the font. So if I run this again, so there's the font at the bottom, which is the original one that we've done. He's now got super fat font, and it looks really, really cool. I love the hearts. So what we're going to do is we're going to use this HUD now in the game. So we're going to use these in the game. So what we need to do an export. Export everything in there. So that's done that. So we are on version 9. And then we just need to change here. So version 9. Where are we? Version 9 to 2021 10 21. So that's that, and copy that, put that there, put that there. Right, so we should be able to run that, and it should have the new. There we go. Look at that. Nice. Right, let's see if quasi indicator's still working. Nice. Should go all the way to the end. Right, so the next thing we're doing was this, the timer. And we want the timer to slowly work its way down here, and then boom, we run out, yeah? So we've created all the graphics in, not there, in here. So let's just knock that down a bit. And we'll boost this one. So we've created all the graphics here, yeah, to do the timer. Now the timer is going to be slightly different than the quasi indicator, is because the quasi indicator will move up and down the scale, as the timer is only going in one direction, which is that way, yeah. So it's going to start full and it's going to work its way down to not full. So oh right, okay. Let's grab it. Let's grab it. What's up? What's up? What, Aston? Where am I? Oh yeah, I'm putting it there, aren't I? Replace. Does that look right? Stuart, does that look right? Yeah? What have you changed? Anyway, let's export it. Let's run it. You missed one pixel. Right. While Stuart's working on that. So we're going to be working on the gauge. We're going to be working on the timer. I'm going to try and get the timer up and running. So I think that was in map. So we're going to be, it's going to be using, done. Oh, there it is. Right.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Hey, Sausage Toes. Thanks for subscribing. Oh, 3 months. And you're on the screen. No, it's not working, mate. I've got to sort that out. Don't worry about that. I'll have it sorted out by next stream. Right, let's get this sorted. So copy that to there. To there. Right, and then reload it. Has it changed, mate? Did it actually change? Open. Well, it says it's that one. Oh, right, okay. Right, so let's export it. Let's just run it before we get into the timer. Is that better? Those hearts do look nice. Those hearts do look nice. So, what we're going to try, what we're going to try and do is this timer, while my voice holds out. Right, so we're in the map. So it's going to be similar to this code where we're displaying the quasi position. So we'll grab it, but it's going to be slightly different. Grab that, put it there. So this is now display timer. Right, so our timer is going to be based on, so we are 8 characters. I think we're 8 characters. Memory serves me, I think it was 8. 0, 1, 2, 3, 4, 5, 6, 7. Yep, so 8 characters. So that's a total of 64 pixels. Yep. So a full timer is 64 pixels. So therefore, we are going to be subtracting fractions. You're a pain. You're a pain, you know it. Ashton. So we're going to be so we got 64 different positions of the timer. So that means if we subtract 1, the timer will go dead quick. Yeah. I mean, if we tie it into the raster, it'll be 1 second. It'll be gone. So therefore, we need to have fractions. We need to have a timer fractions. So let's get into the constants file. Game constants. Right. So there's the speeds. Right. So timer constant. So timer reset value. So that's our full value, yeah? So our other values, so timer decrease easy. So, you remember how decimal fractions worked? Did I put it in here? I can't remember. Did I put it in here? Game storage. Did I do any sort of mathematics about No, teach you. Okay. Right. Fractions. Decimal fractions. We'll go over that again. So I'll do it here. I'm sure I've done it somewhere. Right. So, decimal fractions. Is like this. So, hold the binary whole numbers. Yeah, I did it in Neptune Lander. Right, binary whole numbers go up like this. 0, 1, 2, 4, 8, 6, 16, 32, 64, 1, 2, 8. Etc. Yeah? And that is defined by this. Yeah? So we start here. Start there. Ooh, I can see this is going to be a lot of writing. So we start there, and that is 1. Yeah? 2, 4, 8. Yeah? So I'm just going to do those 4 bits. Then you can work, you know what the rest is. So that's what a whole number is. Now the decimal fraction is like this. Is like this. So it's 1/2, quarter, 1/8, 16th, 32th, 64th, and 1 to 8. Just make sure I've got the right. So a half. Oh, and the first number's 0. If it's all 0, it's 0. Yeah. And the way that works is we're doing it here. So let's add another line in here. Right. So this is 1/, right? So that becomes 2, 4, 8. This one is 16. Yeah. Might as well do the rest. Do it V. 2, 4. 1/16. In fact, I could have done that there, couldn't I? 1. Oh, undo. Could have done that there. 1/6. Right, let's get rid of that. So this is 32, 64, and then 128, and then 256. Right. So we might as well put that on as well. So 1, 2, 8, and then 2, 5, 6. So binary fraction is 1/, and then it's in reverse order. So with a whole number you go that way, and it's 1, 2, 4, 8. For binary fractions you go that way. So if you want to say in a binary fraction, give me 3/4. So 3/4 in binary equals, using the binary fraction, is 1,1,0,0,0,0,0. That's 3/4. So it means that when you subtract that number from your whole number, it won't actually subtract it on the first time round. It does it on the second time round. So we're going to have, we'll cut timer decrease fraction easy. So we're talking that we run at 50 frames a second. So for every 50th, if we want it to move down 1 pixel every second, so if we want the whole game to run for a second, we need to do as close to a 50th as possible. But we don't want the game to run for just a minute. We want it to run for longer than that. But we're going to do it for just a minute, so you can see it being sucked dry. So we have to work out what's a 50th. So that's going to be a 30. That's going to be a 32/48. That's going to be that, isn't it? 16th and a 32th, which is a 48th. Make it run for 64 seconds. Yeah, I can see. How are we going to do that then? Because our raster is 50 frames a second. But we can do it for that anyway. So 1/64. So a 64th is going to be equal to half, quarter, 1/8, 16th, 32, 64, 128, 256. So that is 1/64. Alright? And that's how we're going to do it. So we'll have normal, and we'll knock that up and make it do half the time. In fact, no. No, yeah, half the time. And then hard. We'll mess around with the numbers, but hard will do that, which is going to be a 16th. So that's our reset value, and this is what we're going to take away from our value. So in game map, we're going to have this. So this is the actual, right, so this is our actual timer. And it's not going to be a word anymore, it's going to be a byte. And then we're going to have number of characters and remainder. So we're going to have the same system as we had in the position. Yeah, Nico, what you want? Hello, hello. You had a drink? Your mouth's wet through. You had a drink? Alright then. Look, I'm busy. Alright? Go lie down. Right. Oh, I've got both of you ears, have you? Guys, lie down. Come on. Lie down. Let's shift out of the way. There we go. You can see them. Right. So we're not going to be using that. We are going to... Oi! Out! Lie down. Lie down. Come on. I know. Goodbye. Come on. Lie down. You up? Yeah. Right, so we're using the actual timer inside this routine as our timer. So we're not getting anything from anywhere else. We're just going to keep it all self-contained, yeah? So we don't need to do that, and we don't need to do that either. So to get the characters, we need to divide by 8. We need to divide the actual time by 8. So the best way of doing this is we'll copy the timer and we'll store it in number of characters, and then we'll AND it with that'll give us our 8, and that can be the remainder. Right, so now we just need to divide the number of characters, which is now our actual time, by 8. So divide is logically shift right. And do that 3 times. So that's divide by 2, divide by 4, divide by 8. Now I'm not going to do all the dividing again, because I went through that in the last stream, how to divide. So now we've got the number of characters and we have our remainder. So in the quasi we have to keep refreshing the gauge because the pointer moves around. So we have to keep refreshing the gauge. What we're going to do here though is we are going to only go straight to the character that we need to, and then change that. Should work. So we're going to round this out because I'm not convinced that that's going to work. So I'll keep that there. So we load the reminder. That's the characters, isn't it? That's the characters. Where's the characters? So our character starts there, 91. So I need to make a note of that. 91. I'll put that up there as well, because we'll forget. And then we load the number of characters and then store it in where we are. Now, this was 22, this is going to be 21. Right. So that's displaying the timer. Now, if we're going to run the timer, in fact, that needs to be a word. It's better. And it's not the actual exposition. This is the actual timer clock. 0 to 64. And the reason why we're using a word is because we've got the decimal fraction in there, remember? So every time we display the timer, we should take off the fraction. So let's have the what did I call it in the constants? Decrease. Let's call it that. All right, and then we can do the whole thing here. Aston, what's the matter, mate? Hey? Yeah, dear. Right, so we're going to load the actual timer. Actual time. Now, I need to do this. Yeah. For some reason, they've got it on them this evening. Actually got it on them. Which is good, seeing as what they've gone through just recently. Right, so we're taking the actual time, which is the fraction part. So the actual time is the fraction part. The actual time plus 1 is the whole number. So, you know, like it's low high, we are doing fraction low, yeah? So then we need to set the carry, subtract that, store it in actual time, and then branch if carry set to bypass deck. And the deck is that. Yes, we have them, mate. We have them. Yes. You guys like these fellas. All of them. Yeah. I'm not saying that, mate, because they'll go bonkers. They've had enough. Right. So every time we call the display timer, it's going to decrement our timer, and then it's going to show that on the screen. So what we need to do is we need to initialize the timer. So we'll do that up here. Dude, you're mad. So we're going to load the, what have we called it? Timer decrease fraction. Store it in map dot timer display dot there, and then we are going to LDA hash reset value, and then we're going to store it there, but this one is going to be actual time plus 1. Right, that doesn't like map for some reason, but it's loaded. Is it loaded in? Oh no, it's not. Okay. Right, so that won't work because we're not displaying, we're not calling the display routine, so we're going to do that. So we'll do that in the HUD because we've got lots and lots of time in the HUD to do whatever we like. So we're displaying the quasi position, so we'll JSR map display timer. That's what I called it, isn't it? Yeah. Right. This should slowly have a timer going down. There you go. Oh my god, it worked first time. Yeah. Now the problem is, we need it in the timer. In the timer, we need to test for 0. So we need to load the actual timer +1, and if it's equal to 0, then we just want it to not update. So we just need, so if it's not equal to, go there. If it is, just return back out. So we run out. So that should, when it runs out, it should stop, because we don't want it going past the value, yeah? Because the display timer is not, we're not testing the timer in display timer. We're going to be testing the timer during the game logic to see that when we die. So it's going to be tested in the death part, I suppose, which we've turned off at the moment. So hopefully when that gets to the end, it should stop. We'll wait. That's, oh, we're up over halfway. It's a long time, isn't it? It may not be a long time when you're in the throes of the game once we get it going. Because we still haven't determined what the end goal is of each level, and we haven't determined whether we're going to have power-ups or anything like that. We need some sort of, right, here we go. There we are. Excellent. No. Right. I am wondering whether we should have the last line still intact. Don't know. When it runs out, should we leave it like that, or just have it with the last pixel so it looks like it's like an empty tube? What do you think? Yeah. Yeah. But that's done it. It worked. I mean, if we do mega hard, how fast would that be? Alright, let's see how fast this one is. Whoa, that is quick. That is quick. 1 red, 2 yellow, the rest green. Yeah, I mean, leave the last line. Yeah. Right, we can do the leave the last line. That's dead easy, because that's it. That's here. compare with 1. That should then leave the last line in. Just thinking how we can do the colours. There you go. So we've got the last line. How would we do the colours? Yeah, I suppose. Yeah, we can colour it. No, the colour will get copied from the map, and they're all green. That's not a problem. What I was thinking was that that in the map here we could activate this, but instead of it being screen RAM, we could activate it to be the color RAM, yeah. And this is what I was thinking of. So if I do that, and then instead of this would be the color RAM, like that. And what I was thinking of was, we know the number of characters, yeah? So we can test the number of characters. So I was thinking that we could do this, where we do... Am I using X in here? No. So we could use X. LDX, number of characters, and CPX. What was we thinking? 1 red, 2 yellow, so that's 3, or... One red, 2 yellow? Okay. Yeah, we can do that. No, we have 8 in total. So I was just wondering whether we have 4 green. 4, yeah, that's what I was thinking. 4, 3, 1, yeah? So let's put that there. Right, so load. So compare it with 4. So initially we're going to load LDA hash the color that it's using, which is light green. Right, branch of carry set, so that's equal to that. We're going to looper. Right, CPX hash 1. So LDA hash yellow, wasn't it? Yellow. Then we CPX hash 1, branch of carry set to looper. No, 2. If it's equal to, right, so that's 4, 5, 6, 7, right. Then it's 2, 3. No, that's got to be 1, isn't it? And then if it's below that, then LDA hash red. Store it into the color. Right, let's see if this works. So this is, we'll see if it works, and then I'll explain it. So we should be green until it hits the E, I think, and then it should turn yellow. There it is, turns yellow. And then it should turn red at T. Oh, look at that. Look at that. There we go. How about that? Does that work? I'd make red 2, then looking... You'd make red 2? Okay. So 2 yellow, 2 red. Yeah? It's gone into yellow, then it'll go red. I think that works, doesn't it? That's when it's on the hard counter. I'm not going to go on the easy one because it would take forever. I don't know. How many's on? Not sure. Anybody there? So we don't need that. Don't need that. You're 68,000 in. They're watching you. You're not streaming, are you? Ooh. 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 Andy, that was cutting. Oh, felt that one. Right. Let's just get rid of some of these because we don't need these now. No, we're not copying, not screen switching on the HUD. Oh. I did. Oh, he's restreaming me. Right. So we've got that. So that's the first thing I wanted to do today. Was to it's hosting. You can host, Stuart. You can host me in your channel, and it'll come up here saying that you're hosting me. If you go into your channel and it's I think it's content, hang on. The stream manager, there's a button that says host a channel in your stream manager. And then when you host me, it should come up on here saying you're hosting me. Oops. I want to be in there. No. There's it looks like, how many buttons have you got in your here? Right. Whoops. This one here, host a channel. This one. You have 4.
Hello, John here. Someone's hosting my stream. Oh, next thing they'll be nicking my code.
Oh, Andy, thanks for hosting me, mate. How are you? Do you have a plus? Do you have a plus here? No, do you have a plus? Because then you can add. Yeah? And it's in community. You do plus, click the community tab, and then host channels there.
Hello, John here. Someone's hosting my stream. Oh, next
there we go.
My code.
There we go. That means now that your Twitch stream is showing me. Let's have a look. Well, it should be, I thought. Yes, it is. It's hosting me. While Stuart is offline, check out Old School Coder. A raid is where you pass the baton. So all your people that you've got, you would raid at the end of the stream and pass it on to somebody else. And then they would join that stream. That's what raid is. Right. Yeah. Right, so the next thing I was wanting to do was to start the to start looking at collision detection. So we've already got some sort of collision detecting going on because I have if I can find it. Where is it? I thought I had it somewhere. There we go. So I'm already doing hardware testing, collision detecting. So this one, I think this is sprite on sprite, and this one's sprite on background collision. But the problem is, here endeth the lesson. The problem is, sprite on sprite collision detection is going to be troublesome for us because we have two sprites on top of each other, yeah? And so they're always going to say they're colliding. Now, I found an article on how, here we go, it's here, this is it, in Codebase, on how to do collision detection. So they've got the simple hardware one, which is okay, but unfortunately it won't work for us because we've got sprites double layering all the time. And hey, Docster. And then we've got the software collision detection, where it's a whole bunch of mathematics. But I want to do a hybrid, which is hybrid of hardware and software checking. Yeah. So what we do is we check to see if we check the hardware collisions to say we have a collision, and then we run through our sprites to find out what's colliding with us. And this is the detection routine that's in Codebase. So I thought, okay, seeing as somebody's already done it for us, might as well. So I've where have I got it? I think I put it in sprites. Did I put it in sprites? Lib sprites. Can't remember where I put it. Macro set. What's that? Determine actual on screen. Animation sprites. No, I didn't. Oh, where did I put it then? Oh, lib collisions. That might be the badger. No. Where did I put it? I thought I copied it in. It looks like I haven't. Look at X. Well, it would go in there anyway. But I'm sure. I wonder if it's in... Ah, here we go. Bad guys. So I'll put it in there. This is it. So, what we need to do is we need to work out which sprites are colliding, yeah? And then once we worked out which sprites are colliding, they're the two bits, or the bits that have been flagged as in collision. Now it means in collision with anything, any other sprite. We have to test the position, then test the positions of those sprites against Quasi to see if we had a hit. Yeah? That, boom, we got hit. Excuse me. So, this is the routine that I've borrowed, liberated, borrowed. Oh, I've got rid of it. Oh, I must have closed it down. Yeah, I closed it down. Oh, well. So, this is what I liberated. DO1E. Yeah, I think that's the one. Constance, hang on. DO1E, yep. That's sprite on sprite collision. So, what we're going to do is... Right, it was in the bad guys, wasn't it? Bad guys. Here we go. So, in here... So, let's unrem this. I know it's going to be... It's going to give us a lot of grief. But, the way I want to... By the way, welcome to the stream... Unridge. You're reverse engineering a game now. I do that as well. We're in the middle of Myriad, but we've put it to one side for a bit. We did Grid Runner. We've done Tracks, Dig Dug. What else we done? We've done another one, I think. Anyway. Oh, well, welcome to my streams. See, I knew I'd be famous one day. Right, so we're gonna borrow the code out of Codebase, and we're gonna do that hybrid. We're gonna let the hardware tell us there's been a collision, and these are the sprites in collision. And then what we're going to do is we're going to run through the sprites that are not quasi. So the two sprites that are quasi we're not going to test because we know they're... And then we'll run through the other active sprites on the screen using our staging multiplexer now. And see, using this routine here, if any of them are in collision. Yeah? So we need a way... we need a way to say that this sprite is in collision, yeah? So, if you remember, we've got an array of bad guys up here somewhere. Here we go. So we have an array of bad guys, and so we need now a way of being able to say whether that bad guy is in collision with us. So... Let's create another array. So that is now going to be our indicator that this dude, this bad guy, is in collision with us. So let's get back down there. Bless you. I've given her the lurgy. You got God bless on the chat. So every time we run this sprite collision detection system, we need to reset that array. Yeah. So let's lea #0 reset looper, store it in, let's do this so I can get up there quick. Let's make it so you guys can see it. Store it in that, comma y, INY, CPY, hash, maximum, logical sprites, branch not equal to reset looper. That's it. That should have reset our bad guy in collision array. So what we need to do now is we need to do what I was doing, so I can get rid of that now. We need to do, in fact, let's do that and move to that. So we need to do this here. Yeah. So I'm going to rem this out because the sprite collision byte, once you've read it, resets. So you can't read it again with the same values. It resets, and then as soon as a collision happens, it has a nut. So the next time you read it, you could have two other sprites in a different collision. So we need to read it here, and that's what we're going to do. So we're going to load this, and let's create a place. So hardware collision. Right. So we've created a memory space there. So we load that, and we're going to store it in hardware collision. And of course, it doesn't know where it is. And the only reason I'm doing this is because I may need to change the accumulator, yeah? And we're going to be doing the reason, and we'll see why. So, what we need to do then is we need to I've never written C64 code professionally. I learnt to program as a child, as a teenager, and my parents weren't exactly well off, so the VIC-20 and the Commodore 64 were big spends that we didn't go on holiday when they bought them, and so we couldn't afford things like games, stuff like that. So the only thing we could afford was magazines every now and then, and so we typed all the games, and that's what got me into. And so I wrote my own assembler when I was I wrote it for the VIC by hand, and then I assembled the assembler, so to speak, because once I'd written the assembler by hand, and it didn't have many functions. But once I'd written it, then I wrote the assembler in my assembly language, which then I added load more functions that allowed to do all sorts of bits. And then that was the one that I used for everything else. And I converted it to the PET, so it ran on a PET, and I converted it to the 64 when we had a 64. And I've written word processors. I wrote Extended Basic, which is a video series. I think it's coming to the end now on YouTube, the extended graphics extension for Basic. I wrote a machine code monitor, which I think I did a long time ago. It must have been a couple of years ago now. But I'm gonna be streaming how to modify that so you can program the 1541, because I had two versions of it. One for the Pro. Yeah, I moved it so you could see it. It's there, look. I wrote the assembler, and that was a video series not 2 years ago. But I also wrote another one that allowed you to program the 1541 drive, because 1541 drive has 2 kilobytes of memory that you can mess around with. So I wrote an assembler, a machine code monitor for that. I did write an assembler for it, but there's not much use for it. But the machine code monitor Stuart. It does work, mate. It does work. There is a magazine. There is a magazine called 364, and Vinny interviews coders from back then, game coders from back then, and it's fascinating how some of these people think back then. Yeah, the printouts are up there somewhere. I could get them out, but there's a video. There's a video on it. I think the video is about my humble origins. Anyway, but no, I've never coded a C64 professionally. I've converted a C64 Pro. Well, it was more like a pet program to a BBC Micro professionally for the National Coal Board, but that's about it. Gray's video. What Gray's video? Oh. But yeah, mostly we've been messing around with reverse engineering, but this whole stream is a community project where the guys have got access to the code. They can mess around with it. We've got people messing around with characters and sprites and stuff like that. It's a community development project, and the end result hopefully is a game we're going to be able to sell for charity and make a bit of money for the charity, and then those guys can have their name in lights as part of being the development group. Right, but a good question, got me sidetracked. And Akmafin's been sending basic commands to my display here. I'm waiting for the spiral code to appear, but there we go. No. It's that's what streams are all about. Right. So what's Stuart posting now? Let's have a look.
Hey, I'm
go away, advert. Oh, that one. My interview. Yeah.
In order to give this...
Yeah. The interview I was given, yeah. Right, so we've loaded the sprite to sprite collision register, which will give us what sprites will be colliding. But what we need to do is we need to mask out the quasi sprites. Well, in fact, it's the wrong way around. It's that. So that masks out the quasi sprites, right? Because we don't want to run through and test the quasi sprite with itself, because obviously it's always going to collide. No, we don't want to do that. So now we need to check. We need to run through all of these and see whether we are colliding. Now, this routine assumes that all 8 sprites are being used on the screen, yeah? So we need to be able to determine whether the sprite is being used or not. Yeah? Now, we have a system in place that tells us where the sprites are. Hang on. Gotta find it. We've got a sprite array for the our multi staging sprites. It must be in the sprite library. Yeah, it is. It's in the sprite library. On-screen sprites. I think that's the one. Hang on. Oh, my brain's starting to freeze up. Where's the sprite library? I think it's sprites on screen. Here we go. Determine actual sprites on screen. Here we go. So we've got an array that tells us what sprites are on the screen and what are not. So let me just see if we can find them. There we go. Here's the sprites on screen. And we've got a physical to logical sprite mapping going on here. So we could test which sprite is on the screen, and then we can go back and find what the logical sprite is. Yeah. So so here we will have a bit array that tells us what the sprites are on the screen, and so we can then use this to say, right, this sprite is in collision. Is it in collision with quasi? So our sprite array is here. We've got our X, here we go, we've got our X low and X high, and we've got our Y here. So we can determine our placement. Right, so the best thing to do is this thing, I think it's lib sprites. Yeah, here we go. Grab that. So lib sprites. Boom. Sprite Y. Is that? No, it's .y. So this sprite Y is not correct. It's actually Y. And quasi will always be sprite 0. Always. Sprite 0 and 1 is quasi. So we can reliably know that that is correct. And then here is X low. And quasi will always be sprite 0, X low. And then we're testing the most significant bit, but we don't need to. We don't need to, surely. I suppose we could. Suppose we could. But we don't need to because we can what's that doing there? Well, we'll work through it anyway. So we're starting the looper off. So here we want to be able to run through this if we've collided. And the way I can think, the only way I think we can do this is the bitmap goes from 0 to 7, and we're starting at 7 going backwards. So that works right. So what we can do is we can go logically shift left. Hardware collision. So we're going to logically shift hardware collision left. So we're going to stick the bit, push a bit out and put it into the carry. Then branch if carry clear to next. In fact, it's down here to there. Because if the carry is clear, that means we didn't have a collision on that sprite. Yeah? So we can just bypass it, DX, ASL it again. But if the carry's set, then that's where we can then now check our positioning. So we load the Y value of our sprite that we are colliding with. Now, the problem here, that's the logical sprite. We need the physical. Yes. Lib sprites. Update sprite looper. Load the current logical sprite. That's it. That's what we need to do. Oh, my brain's starting to go. Let's do this here. Right. So we need to get the logical sprite for the physical one. Right, so we'll do this here. LDY. No, that's X. The physical sprite is X. Right. LD. I don't know if we can do LDY comma X. Oh, that's a good one. I always get stuck on these ones. I don't think we can do that. LDY. Oh yeah, we can. LDY comma X. Oh, get in there. Right, we'll do that. So LDY, physical to logical sprite map, comma X. Now that is going to be in lib sprites. Oh, it's little L, isn't it? So let's just work this out. Load the physical sprite, map onto what the logical sprite is. Right, so that should give us, Y should then give us our logical sprite number, and then we can test there. Get in there. That's how we want to do it. And we're not changing Y, so we can use that there. There we go, that should do it. Right, so we're loading the Y value of the sprite that was colliding. We then subtract our Y value from there. And if it's plus, then it's not a minus number. Then they positive it, and then they compare it with 15, which is 21. Oh, so that's the depth. If it's greater than that, then there was no collision. Got ya. Got you, got you, got you. Did you understand that? Did you guys understand that? Do I have to go through it again? So basically, what it's doing is, have I still got the paint program up? Yeah. Basically, what it's doing is, we have two sprites. Oh, I'm going to use squares now. Here we go. Sprite number 1. And sprite number 2. Now, if there's a what it was saying is, if there was a collision, we're testing the Y location, but the Y location is, can I have a big fat pen? Yeah, our location of the sprite is there. Yeah. Ooh, why is it not putting? Ooh, it's not good enough. Oh, okay. I'll let it off. So our XY point is in that corner. Same with this one, yeah? And so what it's saying is the distance between that point and that point, 21 or more. Yeah? If it's 21 or more, it says we weren't colliding. But if it's less than 21, it says, oh, there's a potential that we're colliding. But the problem is, we're only testing the Y. See, we could have two sprites like this. One there and one there. And if we just test the Y, then it's wrong. So we're going to test the X as well. So let's see what the X does. So we're loading the X low, subtracting it. If it's a positive number, fine. If it's a negative number, it's doing a that's a ones complement, isn't it? It's doing a ones complement. Then it's checking the distance of ooh, that's an interesting one. It does a compare, but it doesn't do anything on it. Is that what's in this website? Have I copied it right? Oh, sure, okay. So what's that? What's compare set? So compare sets those three flags. But oh, here. Okay. 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 Where can I order my new motivation? Right. So what's happening is this is setting the carry flag, yeah? So if it's greater than 17, right, then the carry is going to be set. So it's loading the most significant bit and then XORing it with the most significant bit of on the X, which I'm not sure about, to be honest. I'm not sure where that's doing. Let's have a look. Most significant bit. Oh, right, okay. So right, so we've got the same thing. Right, okay, we've got the same thing. Ah, right. We've got the same thing. So, but ours is dot X high. Yeah, that's what ours is. So let's just go back to that. So 0, 0, 0, 0. So these must be zeros and ones, yeah? So what it's doing, it's saying if X is greater than the difference between the two, we load Quasi's high value, XOR it with the high value of the sprite. So let's say Quasi's high value is 1 and the sprite that we're colliding has a high value of 1. So that's 1 XOR 1, which would be 0. Right. XOR. Right. 1 XOR 1 equals 0. Yeah. So it would be 0. But the carry's set, yeah? If it's greater than. So when you subtract 0, right, the carry's set. So if the carry's still set, then it's saying there's no collision. But if it's less than 17, so it's inside, then the carry's going to be clear. So then we're loading 1, XORing 1, which is 0, subtracting 0, the carry's still clear. So therefore there is a collision. That's an interesting way of doing it, because if Quasi was at 0, 0 X XOR and the sprite's at 1, they end up with a 1. 1 subtract 0 is not 0. Because it's always... when the carry's clear, it always subtracts 1. So if it's less than, the carry's going to be clear. 1 XOR with 1 is 0. It's going to subtract 0, which in fact subtracts 1. Alright, okay. Okay, so here, this is where it jumps out. We're not going to be jumping out. We're going to be updating... we're going to be updating bad guys. Because we've got an array now that says that we are in collision. So, where is it? Yeah, bad guy in collision. Now this is the logical sprite number, yeah? Well, it's in 6502. It's called EOR. I just don't want to sound like I'm on a Tigger movie. So it's, you know, EOR is exclusive OR, yeah. EOR is exclusive OR, and I call it XOR. Yeah. That's fine. It's just that when you go EOR, it sounds like you're on a Tigger movie. So what we need to do here is we need to say load 1 and then store it in there, bad guy collision. Bad guy collision, and we want the Y. The Y is the logical sprite. So we store 1 in the bad guy collision, but we're not going to return, because we want to be able to, you know, if we have 2 sprites hitting us. I mean, to be honest, do we worry about 2 sprites hitting us? No, we should, because if we have one of the guys pushing us away and yeah, don't. I'm expecting EOR to be on that in a minute. If the shielded dude is pushing us away and we get spiked, yeah, we need to test for both of them. That is my bot. That is what's controlling everything. What? Turn the fan on. And you can send it a message. Oh. Yeah, it's a pie rack. There's 4 of them in. Ooh, fingers not pointing. There we go. There's 4 in there. There's 4 pies in there. But the bot's on a Pi 2. It's a Raspberry Pi 2. Right. So we are going to loop through all the collisions, and we're going to set this collision array. Yeah, you just put exclamation mark MSG and then you can type whatever you want. Don't put any naughty words in there because I ain't got a word filter on it yet. Well, that's really confused it, hasn't it? he's trying to put more than one message on at the screen. I'm gonna have to make it into a queue so it queues the messages up. Yeah, all the messages showed at once. I'm gonna have to make it into a queue so it so instead of showing all the messages at once. Oh, here we go. That poor Pie 2. That poor Pie 2. Oh dear. But that's my bot, mate. There. Right. So, we're running through and we should be able to see if we're colliding. So what I'm going to do is I'm going to take this and let's put it in, so it's in bad guys. Let's go in logic. Right, so we'll put it in here in the HUD space. Put it in the HUD space, game bad guys. I'll leave the poor thing alone. Right. So we're gonna put it in the dead space. We're gonna do all this in the dead space in the HUD. And we need to see where the menu is. Right. So let's do that. Oh, that's because I'm in the wrong one. Let's do that. 3D effects, yeah. Right, I need to find the memory space for the bad guy array. So I am looking for that. We are looking for byte dump. Do a search for that. Right, so we're looking at 8F09. AF09. Right, so 8F09 is here. Right, so it's this lot here. So we're going to see if we can cause a collision and see if any of those flags fire up. Right, let's see. What space do I want to put it in? Let's put it in that one. Oh, that's struggling, isn't it? That is definitely struggling. So we'll go back. Right, we'll go back to this. We can see them. So we're going to see if we've got any collisions happening. So, oh, there's one there. What is going on? Oh my god. It's going to be doing that forever. Right, so we are getting a flag here. So if that's 0, 1, 2, 3, 4, 5, 6, 7. Oh, I need to figure out. Right, let's do this one at a time. Let's oh, come on. The poor thing, the poor Pi 2. Right, let's do this. Right, so we should see a glimpse of a 1 on the arrow. I think it's just too fast, the arrow. Right, let's do... Right, there's the spike. Right, so the spike should be giving us a 1 all the time. And it's not. Why not? That's giving us a 1 there, but I think that's the... I think that's the dude, isn't it? Yeah. That's this one here. You break my bot, or even worse, break my Raspberry Pi. I'm going to put a Q on that now. I'm going to put a Q on it. Okay, so this is not quite working as I expected. Right, I'm going to put a breakpoint in here somewhere, because it's not working as I thought it might have worked. So that's the reset. Maybe I should. Oh, I'm not going to reset it for the moment. Yeah, I've learnt that. Right, I'm not going to reset this. I'm just gonna see if any of those array. Oops, wrong one. If any of those arrays get set to 1, that'll give me an idea if it's working. So 8F09, or it will not be that now, will it? It'll be. Oh, it's in the same place. Okay, yeah, 8F09. Right, let's get down there. F09. Right, so here. Right, let's see, because it's not resetting now, so it's not always purple. So we're going to find out if we're going to get any flags set. So we go up, come across. Do we get the arrow? No. So the arrow doesn't recognize. Do we get the spike? Well, we've got some here. And it's got done again. But right. That's... Yeah. But here, that's not... Right, so we need to work through. We need to work through. So we're gonna set a breakpoint. Yeah, I know you could put it back to 0, and that's what I was getting ready to do, but I want to put a breakpoint in. So, I'm going to put a breakpoint here. So when we have a collision, we will hopefully break. So it's not going to break every frame, yeah? So we'll go to 8.
Hi, John here. Another subscriber. Stay a while. Stay forever.
SP 5 months, mate. Thank you for subscribing, mate. Welcome. Right, 8. The 8F09. Hopefully it's in the same place. It is. It looks like it's in the same place. Right, let's see if we can get this thing to collide and then run through it and see if it's working. So let's see if the arrow's gonna collide with us. Oh! Well, that collided. What did I collide with? I don't remember colliding with anything. That is colliding with what? What was that colliding with? It's done it again. Right, DO1E. OF. So that's the first 4. 1, 2, 3, 4. So it's saying it's collided with these two, but they're nowhere near. Nine 2C1. No, there's not a maths issue going on. We're loading DO1E and it's got OF. There it is, OF. Now, the two sprites, 0 and 1, should be colliding with each other, which is right, but I've masked that off. Why are they? Is it because it says they're on? Let's have a look. Pointer. Oh, this is probably the reason why. Hang on. Ah, that's why. They're on top of each other. Okay, that's fine. Let's go back to where we was, which is not that one, not that one. That one. No. that one. Right. So these two are off the screen, and so they're colliding, which is fine. So we'll test those. We'll test that maths. Okay. So what it's saying is all four of these are colliding. OF, yeah. But we're masking these two, so it's saying these two are colliding with each other. The test is whether they're colliding with me. That's the test. So we'll run through it. We'll see. So load Y with so that's coming back with sprite 7 on sprite 3. 0, 1, 2, 3. So that's that one there. Yeah. So we're loading XLOW 90, subtracting from me, and we are a negative number, so it makes it a positive number. My brain's screwed. Right, so it's 16, compare with 15, it's bigger than that, jumps out. Right, go to the next one. ASL, is the carry set? Yes it is. Right. Load sprite 6, so that is the man. No, that's not. X is 2, 0, 1, yeah, it's the man, so it's doing this sprite here. So we load its X, which is 8C, which is correct. Subtract us becomes a negative number. We make it into a positive number. It's bigger than 1.5, jumps past. Right, do the next one. This should be a carry clear. It is. Jump it. Right, okay. So we're going to end up with this. So we need this. Ooh. Let's take. Right, 8, 9 to F8. Right, F10. Let's press space bar on there. I want it to stay where it is. Right. That's it. F11. Stop messing around with my bot. Right. Let's get in the middle of this lot. Right, so let's get on here. It's 9 to something something, wasn't it? Nine to there. That's where it is. So that's where it is. That's where I wanted it. Right. So we've got a collision, and we're colliding 4 again. So this is these 4. That's fine. It's not colliding with us, so we'll just run through it. So it's still colliding. Right, that what are you doing? Right, so we right, I'm just waiting for that. Here we go. So that should be colliding with us. Hopefully. In fact, let's put a breakpoint there. Get rid of that one. F11. Alright, so nothing is showing. Oh. That poor thing. Right. So, we're not even hitting this. I am wondering if it's down here. Let's put a breakpoint there. So that's doing the Y. This will be doing X. Right, come on guys. Let's see one of you getting... Here we go. So, but that's off the screen. Right, that's off the screen. So, oops, wrong one. We'll keep going until we get something on the screen. Here we go. Come on, keep going. Keep going. You must be colliding with us now. Right. So Y is 7. So that's our virtual sprite 7. Our actual sprite is 5. 0, 1, 2, 3, 4, 5. So that's not the one we want. We're looking for sprite 0, 1, 2, 3. There we go. This is our sprite. Sprite 3. Actual sprite 5, which I think is right. That's going to be doing that for a while, isn't it? Believe. Where's believe? Oh, believe to be missing. Right. So this is a sprite that is colliding with us. So we're going to find out why. If it's doing it. Right. Load A. F6. Subtract us 10. Right, we're within striking distance. It's alright, mate. It's alright. It's gone through worse. Right, so we're definitely less. So now it's loading in our high bytes. So they are both zeros. So load. So it's saying we're 1. Are we 1? No, we're not. Right, okay. So there's something wrong there. So 0912. Alright, Stuart. See you later. 0912. Oh, it says that they were set at what? Oh, John. Plank. What a plank. What a plank. Ah. Such an idiot. Right, okay. Right, the problem right, the problem is our arrays are stage coordinates, not screen coordinates. See you, Docster. So our problem is that we're comparing stage coordinates and we shouldn't be, because that XOR is not going to work. So we need to compare stage coordinates properly. Oh, head fuzz. So this is not going to work. Yeah. So we need to do what we've done before, and we need to okay. I wonder if it'll work if we do. Will it do? If it's clear, I wonder if we subtract the stage high. Because the carry will be clear if it's inside. If we subtract the stage high, that will subtract one more. So it'd be FF. We can check for FF. Let's try that. Right, so we're modifying it because we're talking stage coordinates, not screen coordinates. So we're going to load our value. In fact, we'll do it the other way. Did that do that? Did that do upside down characters? No. Well, I was going to be impressed then. I was going to be impressed. Oh, it just came out blank. Right, I'll have to. There's a character set in there, I think. I'll have to see what it's got. Right. So what we're going to do is we're going to. Yeah, we'll leave that, but we'll do subtract. Subtract that. So if I'm at 1 and that's 1, that'll be 0, but it'll subtract 1 because, and we'll just do a plus. If it's plus, that means, but if I'm at 2 and they're at 0, subtract 0, that'll still work. Right, let's try that. Let's try that. Right, so I want to put a breakpoint there. Get rid of that one. Well, in fact, I'll leave that one in, because I can run through it then. Oh dear. Right, let's go. In fact, let's jump. Right, that's jump. Right, okay. Let's jump on there. See if the arrow hits us. There we go. Right. So we know... I don't know if it's got all the characters in, mate, to be honest. I'd have to have a look. See. Right, so we've got a proper legit collision here. So the arrow is colliding with us. So this is going to be where we'll be able to find out if it's working or not. Has it broken it? Oh, have you broken it? Hang on. Hang on. Let's see if my... let's see if it's thrown a fit. No, it's still going. Oh, dear. Oh, dear. Oh, dear. Cannot read property of length. Oh, dear. Oh, no, Ackman Finn's broken it. Oh dear. Ooh, minus points. Oh, I don't know how many he's got. Yeah, I'll let you off. You're testing it. That's why I need to figure it out. Aquafin, the destroyer of bots. It should be still working. I think the AMK points are still... Yeah, the AMK points are still working, so it's just the message system's broke. Oh dear. Oh, there we go. Yeah, everything's run by the same bot, so the overlay's run by... The overlay that you're seeing is run by that bot. Oh, he's off again. He's off again, look. Right, so back to this. We've definitely got a proper collision going on now. So load Y. So we know it's sprite 2, which is 0, 1, 2, which is this one here. So we're going to find the logical value for it. So we are logical sprite 4. Then we're going to load its X, which is that. Is it the X? No, it's no. This is the Y. So we're testing the Y. Then we're subtracting from us. It's positive. Is it less than 21? Yes, it is. Right. So now we're testing the X. So we're loading X, which is 28. Yep. Subtract mine. And it's still OD, so it's still left than. Right, so we're testing the high one now. So here we go. Load 1, subtract it. Ooh. That's not good. 912. 912. So we are 0, 1, 2, 0, 1, 2, 3, 4. Why did that come back with FD? Why would that be FD? So if it's 1, subtract 1 should be 0. Hey WauloK. Why would that be FD? Right, let's do that again. Right, so it's definitely colliding with us, so we'll run through this because we know that that's doing it. And so this is now taking the X So the carry's now clear. Right, so we load 1. Right, subtract. I don't know if you can hear Aston snoring his head off. Right, subtract. So accumulator minus memory minus the inverse of the carry. Right, so let's work this out. So the accumulator is 1. The memory is 4. So 0, 1, 2, 3, 4. So that's 1 minus 1 is 0. The carry is 0, so it's minus in another 1, and because we are pulling from the carry and it wasn't set, FD. Right, okay. Okay. So we still need to work out a little bit more of the maths. So, I think we should branch your carry set to there, because if the X low is not anywhere near it, let's drop it out. So then we'll do the set carry there, then do that. Right, let's see if that works. Oh, got a fuzzy head. Ugh. And I've run out of my pop. Nah, it's alright. It's alright. I'm just seeing if this is going to work, and then I'll call it a day. Right. I just want to end the stream on a high. Right, jump onto there. Right, come on, Arrow. Right, here we go. Right. So that's the Y. Not bothered about that. Right, this is the X. Right, so 900. 900. So we are 900. Right. Let's shoot. So 2C, and we are 39. Okay, so 2C subtract 39 is a negative number. Inverse it. OC, yes, that is. It works. Right, so that is within, so we should carry on. So we set the carry, we load 12, so this is where we are, we're at 1. Subtract what they're at. Oh, FE. So 912 and X is 4. Oh, X is 2. Oh no. Oh no, 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 no. No, that's wrong. That's wrong. It's not X, is it? It's Y. Y is the logical number. Right, let's do that again. Right, let's do that again. Right, off we go. Over we go. Right, let's jump on the platform. We'll wait for the arrow to go past and then jump on the platform. Right, here we go. On the platform. Right, come on, arrow. There we go. Right, so we know that bit works. We know that bit works. It's this bit. Right, load 912, which is 01. And that is us. 912 is there. We are looking at 4. 0, 1, 2, 3, 4. There. Right. Subtract 01 is 0. Here we go. Now we... Now it's 0. Okay, so it's not branch if plus. It's branch if not equal to. But is it? Ooh, I think that's where that SBC #0 comes in. Because then, no. I think the flag's set anyway, so we'll try it anyway. So let's go back in. You broken it again. You broken it again. Can't trust you with anything. The break. It's here. I've moved it here so they can see it.
Can't see me there, can they?
No, they can't. So the you know the text at the top.
Oh yeah.
Right. Yeah.
Yeah. I live people.
Yeah.
Did you put that?
Yeah. So, but the putting characters that it's having trouble with, like, yeah, that didn't work. Putting characters in that it doesn't understand, and he keeps breaking it.
Oh dear.
So, I got to figure it out. And also, they've been spamming it. So they've been doing this, you know, like this, and then doing this, like that, and it's been glitching. It doesn't know what to do.
Oh dear.
Yeah, it's having problems.
They are naughty boys, aren't they?
Right, let's get.
Can you turn my plug socket off? I don't want to do it while you're streaming.
Yeah. You finished Minecrafting?
Yeah, it's 11 o'clock.
Right, so here we go. We'll jump on the platform and we'll see. You guys. It's trying. Right, let's so now we're testing this. So load 01, subtract that stage value, that's right. Branch if not equal to. Here we go. There we go. It's working. Right, so let's go to 8F09. 8F09. Right, so that's here. Uh, 8F09, that's there. So we've just set 1. So let's take the breakpoints out and see if the other oh, where'd that go? Eight F09, 8F09, here we go. 9 is there. Right, let's see. We should. Now I've made it so it's not resetting the collision points. So we should. So we've already got the arrow saying it's collided with us, yeah. So let's see if the spike does. There we go. So that's the right. Is the spike colliding with us? Yep, there it is. It's permanently on. Right, so that was the fireball there. So we'll wait for the fireball again. There we go, here it comes. Now that's the fireball. This one here is the guard. There we go. So the guard's now colliding with us. And then this one is the spike, because we're sitting on the spike. So if I move out the way of the spike and get over here, so we should end up with, there we go. So these two, there we go, we've got our collision system working. Our collision system's working. Nice. So there's the fireball. It's just set that to 1, so it's collided. So little man's coming back. No, I've turned off the reset function. So in reality, let me turn back the reset function back on. Let's take the breakpoints out. Here we go, and this one. Oh, extensions had a fit. So this is the reset function, yeah? So 8F09, somewhere around there. Right, 8F09. Here we go. So this is our reset points, yeah? So we should see them flash 1 and zeros and stuff like that. So let's get up there. Right, so we should see the spike. There we go. The spike setting 1, look. Yeah. So let's move out the way and see, right, where's the fireball? There we are, there's the guard there, it's just past us. And there's the fireball. Right, guard's back. So basically, there you go, the fireball. So did it answer you? Maybe that's something I ought to put in, where you can ask the bot a question, it'll give you an answer. Yeah, hey, that's a good idea. Ask bot, and then the message comes up here. I don't know, mate. I don't know. I'll have to have a look. Right. Right. So we have got... Right, so let's run it properly now. So here we go. We've got, in fact, let's put that back to... easy mode, because it's on hard at the moment. Right, so we have got a timer bar that's going down. We have a quasi indicator that lets us know where quasi is in the stage. And now we have a way that tells us that any of these sprites are colliding with us. So we can start now. Now we've got the collision detection system working and it's set in the array. We can now go and look at those virtual sprites, find out what type of enemy they are, and then act on that. What is going on? Does the So as you saw, the timer goes from changes colour depending on how you're running out, and we've now got collisions. Excellent. I think that's a great place to start. We've now got the ability to find out if Hunchback is being collided with any of the sprites that are on the system, and as long as we know what virtual sprite it is, so we should know what the type of the bad guy is, so we can act on it. There. We're getting there. We're getting there. We're getting there. Yeah, well, we're getting there. I mean, we're no longer screen swapping here. This is now just the one screen, as this is screen swapping. So we don't have to put it in two places now. So it's just a case of now start working on the game mechanics, I suppose. Is it the mechanics? So what I was thinking was having power-up pills or something like that, where you can, you know, go for little treats in very difficult places, and you know, something to go for, like, and stuff like that. That they're only one hit, so you know. Same with collapsible floors. I've been wondering how to do collapsible floors. So it's. Yeah. It's something that I want to do. I want to be able to make these maps a bit more interactive, yeah. So collapsible floors and stuff like that, because at the moment it's just reading out the static map, and I've got an idea of how to make the maps more dynamic for each level. Right, guys, I think we've done really well. I'm surprised I've actually got the sprite collision working, which is great, really great. So thanks for joining me, even though I'm not well, and I will see you on the next stream, which is on Monday, and we're going to progress the maze and get the 3D constructs going. Oh mate, thank you very much for the bits. Thank you, SP. Thank you. Alright guys, right, I will say goodbye and I'll give the bot a rest. Yeah, maze is the next one. Take care and I'll see you Monday. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.
Thank you.